So problem 4 is qualitatively different from the other problems that are on the front side of this sheet. So problems 1 through 3 all have kind of a similar look and feel to them. But problem 4 is now doing something different. What would you say is the biggest difference between problem 4 and the problems that came before it? One of the biggest differences is that there are some parentheses present in problem 4 that, again, are an indicator that the order of operations is being subverted on this right-hand side, right? We would do this subtraction here before we did the multiplication by -2. What's one other difference between problem 4 and the problems that came before it? The other big difference that I see is that the variable we're trying to solve for appears in two different places, right? Once on the left-hand side of the equation, once on the right-hand side of the equation. So we need a strategy that can let us deal with both of those features. We need a strategy to deal with the parentheses, and we need a strategy to deal with the fact that our variable is in multiple places. Because if we're going to unwrap that variable, we first need to get all of its instances inside of one box, right, so that we can unwrap that box. Let's talk about the parentheses first. So what did you do in your groups to try and address the challenge of having these parentheses on the right-hand side? So the strategy that you used was to simplify the arithmetic on the right-hand side to realign it with the order of operations, right? To rewrite it in a way that multiplication can take place before addition or subtraction. And you did that, as you just told me, by applying the multiplication that's on the outside of these parentheses, so between the -2 and the parentheses, you applied that multiplication by -2 to each of the two terms on the inside of the parentheses. So if I recopy this at the top of the screen, you simplified this out into -2 times u and -2 times -6. So you ended up on the right-hand side with this, and then what was -2 times -6? Positive 12, right, so add 12, great. Right, so that gets rid of the parentheses so that we can again refocus on what the order of operations tells us about how these two expressions on the left and right-hand side are put together. So the one on the right still hasn't changed, but the one on the left has now been simplified to get rid of its parentheses. So this application is an instance of what we call, so when I use these words later on, you'll know what this means, the distributive property. And there are two distributive properties we'll talk about this semester. This is the first one. We call it the distributive property of multiplication over addition. And we call it that because it's that combination of operations on the outside of parentheses and on the inside of parentheses that allow us to do this. One of the places that distributive property shows up the most often in your earlier math education that you might not realize it is in the process of multiplying a two-digit number. Let's say I want to multiply 16 by 2. What do I end up doing? First step would be to multiply the 6 and the 2 here, right? I'll multiply the 6 and the 2 and get a certain answer. I'm not actually going to do the carries here. I'm just going to, well, you'll see what I'm going to do in a minute. So I multiply the 6 and the 2 together and I get 12. What else do I then end up needing to do? The 2 times the 1, so I also end up needing to do that bit, and when I do that product, I end up with a 2, except that this 1 here didn't really represent just a 1 because it's in the tens place. It really represents a 10, and so 10 times 2 is really what this means, and so I get a 20. And then what do I do with the 12 and with the 20 to get my final answer? I have to add them together. So I've sort of depicted the multiplication algorithm in a slightly different way. But the point is, that the reason that this works is because this is really a reframing of the question, how do I multiply 2 times 16, but written in expanded notation, I could write 16 as 10 plus 6. Right? And so the reason this multiplication algorithm works is because of that distributive property that says I can multiply 16 by 2 by separately multiplying 10 by 2 and 6 by 2 and adding the results. So instead of adding first and then multiplying, we can choose instead to multiply first and then afterwards to add. And we end up with the same answer. This is probably how you learned the multiplication algorithm once upon a time. But if you have kids in the public schools right now, you may also see this sometimes done a different way. And this is a frame that I'm going to come back to a lot over the course of the semester, so I figured today is as good a day as any to expose us to it. This is sometimes called the new math, the lattice multiplication way of doing it. So how does this work in lattice multiplication? Anyone seen this? Yeah.
You put 16 on the top.
Okay.
2 on the side.
2 on the side, and then what?
You draw like diagonal.
Draw in some diagonals. So a diagonal here, a diagonal here. I should have put the 2 on the other side, huh?
Yeah.
Yeah. Okay. And then the box over here, 6 times 2, will fill in with 12. The box over here, 1 times 2, will fill in with 2, written with a 0 in the tens place there. And so now we did our multiplications, and then what do we do after that? We add. In which way? Down the diagonals, because then that honors the place value, the numbers with the same place value. So the 2 ends up here. We'll multiply down this, sorry, we'll add down the 1 and the 2 here to get a 3. And that's where my 32 comes from in lattice multiplication. Another way to do this without the diagonals, because we're going to end up ditching the diagonals later on, is just to write it as, so this connects it to the version we did before, 16 by 2. 6 times 2 is going to give me 12. Make this 10 times 2. That's going to give me 20. And then all I have to do is add the 20 and the 12 to get my 32. So that's the distributive property of multiplication over addition in action. And that helps us to get rid of the parentheses that are getting in the way of our unwrapping the variable in this problem. So now that our parentheses are gone, the expression on the right-hand side has been completely simplified. We still need to get all of our u's into one box, one package, so that we can unwrap and find its value. How did you do that? How did you get all the u's to be in the same side of the equation?
You add 2u and 5.
Perfect. So what we'll do is we'll add. So we'll take and add. If I add 2u to the right-hand side of this equation, how many u's are going to be left on the right-hand side? None, which is great. That leaves us back where we started. But if I do it to one side, I'm going to need to do it to the other side also. And when I add negative 5u plus 2u, how many u's do I end up with? Negative 3. That, by the way, is also another instance of the distributive property of multiplication over addition. It explains why we don't have, why our u's don't somehow disappear, right? The u, negative u and a positive u don't just cancel one another. It's that this u is a common factor for both of these. So when I add them together, what I get, using the reverse distributive property, if you like, I'm going to kind of write that on this side, I get negative 5 plus 2 quantity times u. Right? If I just pull the u out by reversing the distributive property. That's how I know I can just add negative 5 and 2, and that gives me negative 3. And then on the right-hand side, as you just told me, I end up with just plain 12. And now that those 2 first steps are done, now we've reduced the difficult original problem into a problem that looks just like the problems in numbers 1 through 3. And from here, we can apply the reverse order of operations the way we were talking about in the first half of class. I'm going to streamline that process just to save us some time. Adding 18 to both sides, again choosing to deal with addition and subtraction first. We'll end up with negative 3u equals 30. And what's my last step? By negative 3, there we go. And that's going to leave me with a u by itself, 30 divided by negative 3, negative 10. So these 2 first steps, simplifying all the arithmetic using distributive property and then subtracting or adding to get all of our variables onto one side. Those are the 2 steps that we didn't meet at the beginning of our hour today that made this a more challenging problem at the outset. And so the task is to do those 2 steps to reduce it to a problem that we do know how to reverse the order of operations on and solve.